So, hello and welcome everybody to the first VCX official meeting this year, face-to-face, the second time after the pandemic. And thanks to Ben, who organized everything. Since we have a bunch of guests this morning, I want to take the opportunity to give a little short introduction into VCX. VCX actually brings together, as you can see here, the world's camera manufacturers, camera component producers, chipset and ISP vendors, image quality lab, researchers from academia, and other stakeholders from the various camera industries. So this was in the beginning focusing on phone cams, but now we have expanded our area. So we, as you know, we also address webcams, and as mentioned, in the future we'll also address the XR units, especially the camera side on that, but potentially also other areas on the XR devices. So as mentioned already, VCX is a non-profit organization that tries to build standards on camera testing and some benchmarking scores, etc., for image quality and performance evaluation. All the stuff that we do, all the materials that we have are freely available, so free of charge. And we are an open forum. We try to be, or we are transparent of what we do, how we do things. And if you have any questions regarding that, let us know. And I'm happy to answer all of those. We are working on the correlation between end users' expectations and objectively computed scores. We'll get into that a little more detail, but the main thing is that we do want to measure everything objectively, and we want to emphasize all the stuff, all the things that are important to the users, and not the stuff that industry may feel could be or should be important because of market trends, etc. Within that, we provide the benchmarking using the objective procedures. Here's a list of the current VCX members. I hope we're not missing anybody. So if you don't find yourself on that list and you are a member, let us know. So hopefully this is the full list of members, except for a few that do not want to be mentioned here. We have achieved quite a few things over the years. So as you can see, VCX Forum is almost 10 years old, a little over 10 years old. And it was already started 20 years back as a cooperation or as something that was done by Vodafone, European service provider, and image engineering at that point. So we brought it together, and in 2013 we basically decided this should be not something between Vodafone and image engineering, it should be an industry thing, and that's how VCX got funded. Now we have, as you've seen, all those important industry members today that support the activities and also work to make those standards relevant and important, not just to the industry, but also to consumers who base their decision of buying instruments, buying devices on the scores that we provide. So the tenet that we are actually putting up on the wall here are very important to us. So the measurements shall ensure the out-of-the-box experience. So we're not tuning devices to whatever people may think we want. We are also not tuning devices to provide the best image output if that is not what comes out of the box. So we expect the manufacturers to produce something, the consumer unpacks it, starts using it right away, and what he then gets and sees is what we try to test. We shall remain 100% objective, so everything is measured objectively. And we're also transparent. We're independent. Of course, there's a lot of industry manufacturers, etc., are members of VCX, but we want to do all of this independently, and therefore the labs that actually do the measurements that we publish on the websites cannot be related to manufacturers or anybody who has a biased opinion for the image quality testing in this case. And we also seek continuous improvement. And this afternoon and tomorrow morning, when we have the members meeting, that will actually work in that direction. So every few years, of course, we try to make those periods relatively short. We try to come up with a new version of the standard to implement all the upcoming innovations and technologies that you find in today's devices. For example, in the past, we have added cell phone, the selfie analysis. We've added or changed the low light performance values that were actually used. We've integrated video and all these kind of things, but I leave that to the standard department leaders to give you the insight on that in the coming up talks. Oops, sorry. So the labs that actually do or run the tests, I already mentioned, they need to be very objective. So the in-house labs is something that every member can set up. That does not necessarily need to be objective because those results are only used in-house. Then we have the next level up that is called the certified lab. The certified labs can offer service to manufacturers and other stakeholders to run the measurement, and they are audited and so on, but they can also be biased. For example, it can be an ISP manufacturer, etc. But those labs can still not be used to do the measurements that are published on the websites. So for that, it takes what we call a trusted lab that has a lot of experience, that needs to be independent, but cannot be biased by any manufacturer, etc. And that those trusted labs also are kept in sync. So there are devices going around from one lab to another, and the results need to be within very small tolerance between the labs to make sure that regardless of which trusted lab a device gets sent to, we get to the same results. All the scores are based on measurements, on a lot of measurements, hundreds of measurements that we do for each and every device. And those measurements are then put together into a scoring system. And if you look at the different white papers for the different procedures, you see the basis for the score system, and all the very fine details, etc., are left to the procedures that we actually have and that the members can get an insight to. The measurements and the scoring is actually based on studies and statistical analysis, etc., that we perform to find out what the user wants. So one thing, for example, we did a few years back is a statistic analysis of millions of digital photos. I did that with a German service provider for printing and other services, and they get a lot of images, and we analyze those regarding when were they taken, where were they taken, what were they taken with, what kind of things were used in the camera, and so on and so forth. And all these things are used to find out what the user wants, how the user uses a camera, etc., to make sure that the scores we come up with are relevant. VCX Forum is only as good as the activity of its members. So there's no institution, etc., behind that actually does all the developments. It's something that is driven by the members, performed by the members, and if the members don't do the work, nothing gets done. So we actually are reliant active participation amongst the members, and there are a lot of them in this room here, and a lot of them show this engagement and help moving things forward. Good. And once we get there, so for the phone cams, we are there. We have a website, and you can see all the scores, all the things we measured online together with some sample images, etc., so that you can see for yourself what we actually did and where the different things went. And that actually brings me to the end of my introductory talk. This is an example of what a score system looks like. And now I would like to hand it over to Uwe to give us a little presentation on the standards for the phone cam.
Okay, welcome everyone. So I would like to take the chance this morning to introduce into the phone cam profile. So as you know, we have different profiles in VCX that is dedicated to phone cam, the origin of VCX, extended to webcam, a very important profile where a lot of people here in the room are active. And yeah, we will see what the future brings. We will see also about XR profile to move forward. I will use this slot or this seminar here right now to introduce into the what we do for the phone cam profile. So that is the current version, that is an insight into the upcoming version. So that is for those guests that they understand what we're actually doing, but maybe also for the members to get that as a starting point for further discussions we're going to have this afternoon and tomorrow. So yeah, we have already seen the history of VCX, and I'm not repeating what Dietmar said, but just about the versioning. So when we started VCX, we started with 1.0, so the first available. But then we then we had a version 1.5 that was basically the first that was used for a long time, and switched then to another naming convention. So the currently used version for phone cam is a version 2020. That is the current test protocol that we have, and we are working on having the version 2023 released soon, and that's also going to be a major discussions that we're going to have today and tomorrow to finalize the work on version 2023. So giving you some insights into the test procedure. So the version 2023 is a major update or extension of the version 2020. So that's why a lot of things from the current version are still of interest, where I would like to give you some insights. First of all, when we do testing for VCX, we create a controlled environment. So we test the devices under a controlled environment. All labs that are using that should have the same environment. So when we talk about different tests, typically what we do is we perform these tests under different conditions, so that we see how a device performs. And we have the major conditions is bright, what we call bright, mid, low. Bright, that is a D55, so a daylight situation with 2000 lux. So that is, already in the lab. What our research showed is when devices or all devices that we tested at that time reach base ISO, so basically use the lowest ISO setting, ISO speed setting, so that they kind of perform best with a lot of light. The mid situation, that is like a room light or office light, 250 lux with an LED-based lighting. So 250 lux would be like the minimum requirement for an office situation, or is like a home situation indoors. And then we switched for the version 2020. We said we really checked people are using devices, mobile phones, under all conditions, also in pretty dim low light situations. And the expectation of users is, because of the great performance of these devices, that you can actually take a proper image at 10 lux. 10 lux is already pretty dim. That is really like a smooth living room or evening situation, maybe candlelight dinner, but that's the expectation of the user. So that's why we perform tests at low, so 10 lux situation. We use then additionally the flash. So we use if the device has one, so in the low light situation, having an additional LED light if needed. But also like zoom, selfie, video, these three lighting conditions will repeat. We extend that also to an extended low light condition. I will come to that later, and with some other lighting situations. Something important: when we get the device, we always set the device back to factory default, and we use the default camera app with automatic controls. So when we get the device, we do not install a specific app, and we also do not use like ADP or something to get to the images. We just really use the device as a user would do. That is really by starting the default camera app and pressing the button. just to make sure that there's no difference in the procedure when exporting an image through another application or through the a debug protocol. And the analysis is performed on the final JPEG or the final export data, so the data that we can get from the device. I mean, we know some devices store differently than they export, but that's as the user is getting the exported, that's what we use. A major component of the testing is these multi-purpose test targets. So multi-purpose test targets have two great benefits. One is we can test a lot of things at the same time, and that means we save time. It's very efficient. But I think the most important thing is this way we make sure that we test everything under exactly the same condition. So you know that when you tune a camera, there's always finding a good trade-off between color, sharpening, noise, texture. All these things you need to balance out. And if you test them separately, one after another, you might not have exactly the same condition. So the device might optimize for that specific test condition, test target. Here, we have everything in one target. So we have that target and we illuminate that with the different conditions. And then we can extract from this target different metrics like resolution, texture loss, sharpness or sharpening, color reproduction, noise, dynamic range to some extent, shading, distortion. So a lot of things that come from one target and that is captured under different conditions. We can also do that for the selfie camera in version 2020. So that is a smaller version of the test target. So that reflects the typically lower distance. So that we get into a viewing distance or device distance to the target that reflects the typical usage of a selfie camera. Something also very important is a timing measurement. There we have an extended setup to measure like the shooting time lag. So what's the time between pressing the button and actually getting the image? When we first designed VCX, we were talking about like 2 seconds from pressing the button to actually capturing the image. Now we are talking about like minus 100 milliseconds. So we get actually negative sometimes because using ring buffer and so on, so other technologies. It's a different thing than in the early days, but it's still very interesting to see how some devices react. As a device, mobile phones with the permanent focus and with potential negative lag, it is quite a sophisticated setup. So what we need is hardware that will automatically, in a controlled environment where we have a near focus target and a far focus target. So we can synchronize these setups so that we have control delay between that, and then we have the timing measurement devices in the test target so that we can actually measure the delay between getting a clear view onto the target and actually performing the measurement. So that is we're testing that at 2 different delays, and so with that we can really make sure that we measure the performance of the device or the timing that the device needs. Okay. Another measurement that we perform under the umbrella of performance is the optical image stabilization. So the device is put on a mechanical shake generator, you could say. So it's a hexapod, so that the device has a very controlled shake. When we started with VCX, we used a very simple sine wave shake, but then research also for members has been used, and also activities at the ISO to create or to have a natural human handshake. So there is a natural defined handshake, so the device is shaken repeatedly and in the same way, and then we analyze the target for different metrics to get to create a score for the performance. For the version, that is the version 2020, we had the activity to review that for the version 2023, and the nice outcome from that, also due research of members, was it works very well. So it was compared objective measurement with subjective measurements, and it was just agreed, okay, it does work very well, it reflects the performance, so that we're going to keep that. But there has been a lot of activities in that area just with the result, and I think that's also a very good result. We can keep it. It does reflect the user experience. I would just like to take a focus on some metrics that we use, and one metric or one area that is very important, I think, where we do better than other standards is the area of spatial frequency response. So when you hear resolution or spatial frequency response, SFR, still some people think about this target. So I can just say that is outdated. So it's years ago. It has already been removed from the ISO standard. It's still public, people like it or use it, let's say, but it has a lot of technical issues. So it's it is outdated. It's not current technology. Also, what comes to mind when people think about SFR or want to measure the performance of a device is like slanted edges. And I would say, and that's the research also within VCX, that is not enough. Having a look at edges will not give you really the performance that you have in terms of, or the full insight into the performance of a device. So what we just very basic, what we do with the measurement, we do a semi-reference method. So we provide something to the camera, and the camera will turn that into an image. And then we can, when we know about the target, we can tell what happened in the camera, right? So we provide something to the camera, and then with knowledge of that pattern, we can say what's the performance of that. And we make what we do for SFR measurement in VCX. We use different pattern because the answer of the device is different depending on the pattern. So, for example, we use the Siemens star. That's a harmonic pattern. You have seen that, or we will see an image of that. So that's the ISO. It's in the ISO standard 12233, and it's less influenced by sharpening and other image enhancement algorithms. So from this Siemens star, we extract like limiting resolution. What's the level of detail that we get? Then we have a very important aspect for the performance of a mobile phone, and that's what is called texture loss. So that's the loss of low contrast fine details, mainly due to noise reduction algorithms that will perform on the image and may not always be able to differentiate between image content and noise. So they reduce these, like you see there in the teddy bear or in the hair of the mannequin, the low contrast fine details are just removed, and that is what we call texture loss. So what we use for that is a pattern that is called dead leaves. So yeah, basically, so the target looks like that, like on the left. So it's circles stacked on top of each other. And the camera reproduces that, and then we get the image. The nice thing about this pattern is that it has some properties that we can use for the analysis. And it has shown in different activities and different publications that it works very well. It is also a technical specification within ISO for this texture loss measurement. I decided not to go into every detail of this algorithm. If you're interested, reach out. There is the publications on that. It's on the website, and you can also talk to me, but I decided I don't want to go into every detail here. We might spend some time on that. But so just want to let you know, so that is, so that is the state-of-the-art method to measure the spatial frequency response, particularly in presence of noise reduction and loss of low contrast fine details, and it's also an ISO technical specification. So now we have the Siemens star, we have the dead leaves, and where are these very popular slanted edges? Yes, we use them as well. Slanted edges are a useful method, but what we use for that, where we use it mainly, is for the measurement of sharpening. So sharpening is something that happens in images as a way to improve the subjective impression of sharpness to a user. So that's typically by on the edges, so that along an edge you have the edge gets slightly darker and slightly brighter exactly at the edge position. You see that here in the lower right. So that is an example where you see in the marker, so along the edges you have a brighter and darker line, and these can cause some artifacts. So some sharpening, some of this effect is definitely beneficial for an image. It will improve the subjective impression, but too much is also a problem, because that will cause artifacts. It will look too much, too over sharpened, and that is also a problem. So what we use the slanted edge method to actually measure that. And we measure the integral, so this amount of overshoot and undershoot that we have. So that is also a more sophisticated method than what was typically used or is typically used in other procedures, so that we have really a measurement for the amount of overshoot, undershoot, and that we can say, can find like a sweet spot where we say, okay, too low is not good because then the image, doesn't look crisp or the sharpness suffers. But if it's too much, we run into problem of artifacts and these things. So there is a certain region where we leave also some room for breathing, let's say, for individual tuning, for individual decisions of the manufacturers. But if it's too much, it's too much. And we see also devices where it's just over sharpened. So just to, as I said, we have the Siemens star, we have the dead leaves, and we have the slanted edges. And I just want to show you some data. How do these work together? So taking data from a test target here, where we also have all these structures. So if we have raw data, we see it's all the same. So basically, we can, from all these patterns, we can derive a spatial frequency response, an SFR. And if we take raw data, very, very simplified image processing, we get the same results. That's already good. That's our baseline. But as soon as we start to process the image, we apply sharpening, we apply noise reduction, we do other performance or other image enhancement algorithms. These things start to separate. And that's exactly why we did not decide on, hey, we just use slanted edges, we just use Siemens star, or we just use the dead leaves. We use all in combination because they all give us different information. And if you take it too much, so here's an over sharpened image, or let's say the sharpening set to a maximum in the device, and you see that like high contrast slanted edges goes crazy high. But we also see that like the dead leaves is still much lower than the others, so we can still differentiate between that. So that's a very useful method, and that's why we have, when it comes to the SFR measurement that we have in VCX for the mobile phone, we use Siemens star, like on the left, we use dead leaves and slanted edges, and all these are converted into the scoring system. So all will give us an SFR, and from these we derive different metrics, and these metrics will then be generated into a score. So it's a complex system, but yes, cameras are complex. So, but we think that with this, we really reflect the performance of a device, and that we are much more sophisticated in terms than other metrics that are out there or procedures that are out there, as we really get into the details of a device. Other measurements that we perform. I mentioned already, we perform the measurement at the low condition, which is 10 lux. So that means we perform the image quality assessment for mobile phone at 10 lux and do the entire test there. When we discussed what is a good low light performance measurement, or what is a good low light condition, we had the very good point of members that said, hey, we spend so much time, resources, and energy on getting a good image at 5 lux or at 1 lux. We would like to have that reflected into the score. We would like to see that. So, but on the other side, we saw not every device is capable to do images at very low light conditions. So what we decided is, and what we do in the test protocol, we perform the full image quality assessment at the low condition at 10 lux, and we have an additional low light performance measurement. The low light performance measurement is following the concept of the ISO standard for low light performance measurement. So basically it means we capture images of the used multi-purpose test target at 2000 lux for reference, and then we just go from 10, 7.5, 5, 3, 2, and 1 lux. So we go step by step into lower light situations, lower than 10 lux. So that's already pretty dim. But we see also devices performing well in this case. So we capture images, and then we have different metrics from the test target, and we report the low light performance at that light level at which all KPIs are above threshold. So we did some research by creating artificial image or creating images derived from the same raw with different kind of tuning, and then a study has been performed where we decided that what is a good threshold. That means we have visual noise, exposure, color, resolution, and texture. For all these, we have thresholds. So you see that there as a red line. On the blue line, you see that that is the actual measurement at the different lighting conditions. This particular example here now has a low light performance of 7.5 lux, because at 5 lux, the device goes below threshold in the exposure. So only at 7.5 lux, all measurements are still above or below the certain threshold. Another device here has a loader performance of below 1 lux, because at 1 lux, all measurements are still above or below threshold. So you see here, this is a pretty good example. This device managed to keep the metric at the same level at 10 lux down to 1 lux. It didn't really change there. So this is an example for a device that has a good low light management, very likely like multi-exposure processing and so on, but it does very well. So for this device, we can say this has a low light performance of smaller than 1 lux. So actually, there are devices that can perform this kind of performance. And now we have a lot of metrics, and we want to convert that into a score. So how does it? So Vijay, one of the vice president and founding member, he put it as the secret sauce. So that's how do we convert? We have a long list of metrics, and Dietmar showed that it's hundreds of metrics that we have, and this is at the end results in a single score. And if you do that like as a magazine, a photography magazine or something, of course, then the editor's team will decide on that. Of course, our goal is not to use that on personal opinions, but to do that based on research. So what are the different things that we need to control, or what we need to do? So at the first stage, you see that at the lower right, we have to convert the metric into a score. So that means we take a metric, let's say the delta E on the color patches, and we convert that with this lookup table into a score. And the score can go between best would be 1, worst would be best is 1. It can go to 0 for many, but for some where we say these are really critical, it can go into a negative, so that a low performance in a certain area can actually get away or get a penalty also on other scores. So that if you have a really poor texture loss, you cannot compensate that with better colors. So that's how it's treated. So we have some metrics that are converted into a score based on these lookup tables. Depending on the metrics, it's each individually decided what is a good value and is then converted. Also, with this lookup table, we can have kind of plateaus or the same thing. So because it might be that one device is better than the other in some areas, but both are below what the user sees as a critical issue. So if both devices have very low distortion, so one has 0.1%, the other one has 0.2%, yes, there's a significant difference. It's basically double as much distortion, but both is below what a typical user can see. So that's why they all get the same score. So that's what we can reflect in the lookup table. And now we have the score tree. And the score tree is basically summarizing different metrics into groups, and then these groups are forming a larger group and resulting then at the end in the final VCX score. And each of these groups has a certain weight. Each group, the weight is distributed in a way of that sum up to 100%. And so we have to say, or we have to decide like image quality or main camera image quality under bright condition, what is the, how do these weights work together? And you see here different percentages, and that's always how it's weighted. So if something is very important, it gets a higher weight. If something does not contribute that much to the total score, to the total user experience, it has a lower weight in there. For example, we had to decide the main camera makes 80% of the total score, while the selfie camera makes 20% of that. That is, of course, decisions within the group that we need to make, but also like for image quality, the bright light condition makes 35%, the mid makes 25%, and the low, what was it, 35. So there's also a certain distribution. That was, for example, based on studies members performed and could share. For example, that a lot of users use their devices in low light conditions. So that's why we had to adjust the weight in low light situations. Because under bright sunlight, every device can capture good images. But yeah, if most of the user capture images in indoor environment or in low light situations, the score needs to reflect that. And of course, for the next version, for the version 2023, we'll have to review that. We have to review the test protocol. We did that, but also we have to review the metric to score approach. And that's going to be discussions we're going to have this afternoon and tomorrow about how do we change, because we have new metrics, we have new measurements, how do we get them into the score system? Okay, so I already talked a while about the version 2020 or what we do there. That will stay for the version 2023, and we will modify and extend that with additional new tests and new metrics. So I just want to go through what we want to do, and a lot of these are still also subject to discussions that we're going to have. So one thing is version 2020 evaluates the video image quality on a static target. So it's more like video image quality. But what we want is additionally to have video performance on a dynamic target, on a dynamic scene. So you see that here, like example for auto exposure convergence. So how does the device react to changing light situations? And we can do that for the auto exposure behavior, but also for the AWB convergence. So how does it react to the changing light spectra? So if you are indoors, you open the door, so suddenly you have another dominant light. How does the device react to that? Or you turn on the light. How does the device react to that? And you see that here in this example, when light changes for a small moment, the image gets a color cast or gets overexposed or underexposed. So these are situations that typically happen, and we would like to reflect that because we have seen there are devices that can handle it quite well, but there are devices that struggle with it. Also, something we're going to check, or we check, is the frame rate. We identified devices and at least that play with the frame rate also under different lighting conditions. So when we check the frame rate under bright light, typically they have the 30 lux, but it can happen that devices under low light situation cheat a little bit. They still output 30 frames, but actually capture 15 frames per second. So these are tests that we would like to perform as well, and or that we actually do. Also, something where devices struggle or might struggle is the autofocus. So under video condition, they need to refocus. So we can use the setup that we have for the timing measurement. We get a target in front of the camera, give it some time to focus on that, and then remove the target and see how does the device, how long does it take to actually refocus, to notice, oh, I'm out of focus, to refocus. So that's also dynamic measurements that we would like to introduce. Also something that we would like that we take over from, or a lot of that is taken over from the webcam profile, where we would like to challenge the autofocus and the auto exposure and the auto white balance in a different way. So we still have to adjust some things here, but still would like to show that, so that where we can create a challenging scene. So having different kind of backgrounds, having different kind of scenarios, and that is already done in the webcam profile. And yeah, we would like to take things over into the phone cam profile. And again, we also do that in different lighting conditions. So here is a bright foreground, and then you see the different background. We can also do that. I switch that in the medium light conditions. So where the foreground is now just at 250 lux. So it's even more challenging. You see that here when the background, now the ratio between foreground and background is different. So it makes it, in terms of dynamic range, makes it more challenging. Yeah, so we can really stress the auto white balance and the auto exposure here. We do that, or in the current data set that we generated for that, and it's up for discussion if it's going to stay that way. That's what we're going to use this afternoon and tomorrow for. You see here an example where it's just 10 lux in the foreground. So this is really like the scenario, and we have to discuss if that's realistic, that you are in a very dim room and you have a window behind you. So that the only light source in the room is mainly behind you. So you see here, you can manage after a while to compensate for that, but it also results in very critical issues here in the foreground on the face when we have this challenging. So this is really challenging, but yeah, we have to say if it's too much of a challenge, and that's something that we also did, and for the test data set that we have right now, so the selfie camera test in the version 2020 basically used a smaller version of the multi-purpose test target. We decided for the version 2023 in the test data set that we have now for further discussion, where we tested like 10 devices, that we use the 3D scene and the video things that we do on the main camera with video, that we also do that for the selfie camera. It adds a lot of work into the test protocol, but yeah, we have to decide and we have to balance that out. So most of the tests that you have seen now with the challenging things are also done with the selfie camera. When we talk about a main camera of a mobile phone, typically we are talking about multiple modules these days. So it's not the time anymore where you have a single lens on the back of your phone. You have typically 2, 3, 4 cameras on the background that are focusing on different areas. So some are for really extended zoom. So that's why we also said we're gonna test that as well. So really like 10x zoom, long or high zoom factors, so that we can, if a device is used and advertisement is used to say, hey, this device has a 10x zoom, we also want to be able to mention and to show that. So that's why we're gonna add test there, also because we have seen devices offering that still have a significant difference in their performance. So there's not only additional modules that go into the direction of zoom, but also in the direction of more wide or ultra wide modules. So if you say a wide is the default module, a lot of devices have an additional ultra wide module that has even a larger field of view. The challenge with these devices or with these ultra wide is to measure resolution or spatial frequency response in the corner. Because there's a lot of processing going on, and the optical design is of course very complex for such lens or for some design. So the corners are a struggle. So what we do for the ultra wide, we can take a modified version of the TE42 test target. So in the center region, we have all the pattern that we use also for the other tests. So we can do a noise measurement, color reproduction, we can measure texture, resolution in the center. But we have a different kind of pattern to measure it in the corner. And for that, we have this pattern in the center that we can use as a reference, and then we have the same pattern in the corner. And you see that here, this pattern is arranged that way that even if you have a strong distortion, the pattern will stay in the corner. So it's not that it's gonna, so we can always measure in the corner, even if we have a strong distortion, because that pattern extends over the typical chart situation. So even if it was a strong barrel distortion, we would have the possibility to have that pattern in the corner. And you see that here in this example, so of just the device I picked out of the reference data set that we created. So this is the device under 2000 lux. This is the device under 250 lux. And this is the device at 10 lux. So with the projector here, it might be a little bit difficult, but I enlarged that a little bit and made it brighter. So I think we can agree there is not much left of that pattern that we have here. So you can see here at 2000 lux, you still have a certain pattern that the camera can resolve, while at 10 lux it does not. And that is something that we can measure. So we have a look at the discrete spatial frequencies of that particular pattern. And then we can analyze that so that we have the reference in the center and then compare that to the corner. And yeah, we have the data now in our data set. We need to finally review that. But we can give what we want to give is a percentage of the corner to center, so that we can say what is the loss of resolution from the center to the corner as a high-level indicator for what is the performance in the corner compared to the center. So it showed in the data that we have seen so far that it works well, but of course it needs some detailed review and potentially updates. Oh, now that I talked about additional metrics, we of course also have to think about additional modifications to the score calculation. So we have to update the metric to score calculation. And as Dietmar mentioned, we would like to be objective. We would like to use scientific data for these decisions. Well, how we decide or what we do is first is that we create a data set. So based on this data set, we have then information how devices perform. So we took 10 devices in different quality categories from high to low tier, so addressing different markets. And based on these data, based on these devices have been taken to lab, and all metrics, all these tests that we want to do new are performed with these devices, so that we can see what is the range of expected results and what we can do. So that's the data set that we have. That is one of the foundations that we use. An additional thing is, and that is very important, and that's where like an institution like VCX Forum can really play out its benefits, is that we could perform or did perform an online questionnaire. So we took images with these devices and we took a survey of 1,500 people. So a large-scale performance or subjective study on images with naive users to get so to have data that we can correlate with. So now we have a lot of images where we have the subjective study, we have the metrics. Now we can start we can correlate that so that we make sure that if a device has a high score, that it also means it has it's actually a device that many people would consider as really a good device. So from these images, a lot of we used images, and people were asked to give it a score, and additionally to say to justify their decision, to say what drove your decision. And that can now be statistically be analyzed, and we additionally also did some work on enhancing that with an expert study to even better understand this data. So later this afternoon, there's going to be a detailed report from the Instituto Eldorado in Brazil that works significantly on this work. So they will present later this afternoon about the outcome of this survey, because basically you as the members voted that we want to do that, and VCX spent, of course, quite some money on that. So of course you should see what was actually the outcome. So that's something that we're going to see later this afternoon. For everyone who is a guest in the seminar, I just want to highlight, this is really a large-scale survey to get objective data and to see how things perform. So last not least, I would like to comment a little bit on where are we. We're talking about version 2023. And yeah, so there's a lot of work that needs to be done when we move from version 2020 to version 2023. So first of all, we need the technical work, so create the data set, including results and metrics. So first we needed to decide on the protocol and then execute that. Then we need to work on the metric to score approach. So new metrics need a new lookup table. So how do we convert that? We need to create maybe new groups. We need to update the weights, and we need also to update the tools, the software tools that VCX developed to create the score. And then, of course, after that, also editorial work is needed. So the website needs to be updated, the white paper needs to be updated, and report tools need to be updated. So that's all work that has to happen. So where are we? So on the data set, the revision 1 is done. So data set is available, and it depends now on the amount, on the discussions that we have, if it stays with Rev 1 or if we need an additional revision, if we need to go back to the lab and do additional tests. Metric to score studies are done, discussion started, framework is there. Yeah, we just need to, based on the feedback, also the outcome that we're going to have here at the face-to-face, there are some decisions we have to make, how exactly we want to create the score systems. That's a discussion we're going to have also this afternoon and tomorrow morning, so that we can finalize that. And editorial work, I mean, it can be finalized as soon as the other things are done, but also activities started there. So yeah, revision is based on the feedback. We need to see if we need another revision for the data set, if we need to go back to the lab. The metric to score, we need to iterate through revisions based also on the feedback, and the editorial work needs other items to be done. So, but it's all, we are in a very good state. So I had personally had the goal to be ready here at this meeting with the version 2023, but I also saw quite some feedback that we got from the members in the last technical meetings, and that reached me through email and so on. And I definitely would like to reflect that and take that into consideration, so that we can discuss here and come to a conclusion where all members are happy with. So that's why it might take another, let's say, a couple of weeks. But yeah, we are very close to reach, to say we have a final version 2023. So with that, thank you very much. So I hope I could give you a good introduction into the version 2020 and 2023, and also already show a little bit things that we need to discuss here at the meeting. And yeah, happy to move that forward. Thank you.
So quick introduction. If you don't know me, my name is Tony Orchard. I'm the department chair for VCX Webcam. I'm a senior image quality engineer at Intel, and I've been working in imaging for a little bit more than a decade. That being said, I don't really view myself as an expert, just some guy that's found himself in a position to advocate for quality. I just got back this weekend from a trip to Central Oregon, and I was out there with a group of guys in big four-wheel drive trucks, hundreds of miles from anywhere, flying at breakneck speeds through the desert, doing stupid things, and it was a lot of fun. But while I was out there, I couldn't help but think about what we do and why we do it. I was out there in the desert. The only way we could communicate with each other were on handheld radios that were not very clear, that were kind of fuzzy, and at a very short range. We had to speak clearly with very short words, and if there was a problem, we had to stop the convoy and get out of our trucks and talk to each other and figure out what was going on. This wasn't far from the settlement days in the American West, when there was no communication that didn't involve a person on a horse or a wagon. Not too far forward from that point takes me to my grandmother, who was a Bell telephone operator in a small town in Michigan. Back then, if you wanted to talk to someone, you needed to call the operator, my grandmother, and she would know you by voice because it was a small town and there was only a few people on the system. And you would call and say, I want to talk to so-and-so, and she would use a hardline connection and connect your phone to someone else's phone, and their phone would ring, and they would have their conversation. And it required a person connecting a wire to make that conversation happen. And it was still audio only, certainly better than the radios, but still audio only. But what we found is the world has changed. In the last 100 years, communication technology has improved dramatically, and the world is more connected than ever before. At a time when it's harder than it's ever been to travel, to get approval to travel or to navigate changing geopolitical conditions. And all along, cultural values and language barriers impede understanding. So how do we fix that? How do we make it better? Video conferencing has become critical. It's been the critical link over the last, especially since the pandemic, to help us build relationships and to help us to understand each other. A few statistics that I pulled out I think are useful to understand. According to a study I read, around 55% of communication is based on body language. Up until the last few years, most business calls just happen on the phone. And I can think of many times where there were misunderstandings because body language and facial expressions weren't carried across, especially cross-cultural from US to Asia, for example, and vice versa. During a recent survey, almost 90% of people in the survey reported they felt more connected to their teams when they meet occasionally on video. A 2013 study came up with an order of interpersonal bonding, which I think is probably pretty obvious to most of us, but in-person interaction followed by video, followed by audio, followed by text. And in 2019, 77% of video calls were made from a laptop or desktop computer. That's why we're all here. We all work in the industry. We're building devices, we're programming ISPs, we're tuning cameras, we are testing devices, we all have some part to play. But the key thing here is that video can have a profound impact on business and personal relationships. The quality of those video calls can make and break the beginning and the maintenance of those relationships. And a reliable method of objectively measuring that quality has been the missing link over the past 20 years of our technology. The first video camera, as I put in the lead-in to the VCX webcam spec, was in the early 2000s, and it worked at a blistering 1 FPS and was used to monitor a coffee pot. It's now 2024, 24 years later. So where are we going with this? I'll talk about a timeline in a little while, but a core learning from VCX webcam development is that IQ KPIs have to be viewed as a correlated system. The trade-offs that we make when we design cameras, they're not binary, they're not either or, and they don't sit by themselves. They often have relationships to one another, and those relationships change depending on different factors. Component selection, tuning parameters, and subjective preference are just some examples. Legacy methods to evaluate how video cameras work have been around for a while, for most of that 20 years, in fact, well, at least 15. But everyone that I'm aware of has used a hard pass-fail approach. And the problem with those methods has been that they ignore the relationships between IQ KPIs. They just say, okay, here's a list of KPIs, and each one has a threshold, and if you're above that threshold, then you're good. The core ethos of that approach, however, is not to say, let's measure how good a camera is. Instead, they're saying, let's measure how bad a camera can be allowed to be. So when we developed VCX webcam, we thought there has to be a better way. And what we determined was a better approach would be to grade IQ characteristics on a scale based on industry trends, based on real data from real devices, and expectations of performance for that market segment. And all of that has to work and be aligned to subjective image quality studies. That's the basis of VCX webcam. So a short history and how we got here. If you've ever developed a standard or even part of a specification, you'll know this is a lot of work. And I'm constantly shocked that we got as much done as we did in a very short period of time. In February of 2021, I reached out to several stakeholders and partners in the industry with this idea and said, hey, we need something better. Intel partnered with VCX. Dell very quickly joined with us, and the core 4 members of VCX formed what would later become VCX webcam. We went through a very quick period of specification definition, KPI and algorithm development, data collection, subjective study and analysis, and metric to score development, which ultimately led to the launch of VCX webcam 2023 in November of 2022 to much fanfare. Very exciting. Shortly thereafter, the Intel EBO program adopted VCX webcam as a measure of camera quality. This is a program that has a lot of influence in the PC ecosystem and is a key driver to device improvement and quality across all ingredients, in fact. So now that we've launched the specification, since that time frame in November, we've been working on getting labs ready. We've been working on closing some gaps. We've been working on finding the gaps and filling them, because certainly we developed this very, very quickly, and there's always going to be some little things that get missed or need to be adjusted. So we've been doing that over the past year. So next steps, it's May of 2023, right? The first labs to certify are expected to certify in the second half of this year, early in the second half. We're working on closing gaps based on industry feedback and targeting a minor spec revision in the second half. Most likely we'll hit that in November, just because we launched the last one in November. And we'll be beginning work on next generation KPIs for the next major VCX webcam spec release, which will be next year. So let's talk about what VCX Webcam 2023 is. Uwe did a great job covering a lot of the details, the technical details in the phone cam spec. I think it's worth talking about how we work together, right? Within VCX, there are two profiles. There's a VCX phone cam and there's VCX webcam. And we do a lot of things utilizing similar methods. But what we've learned is that there are key differences in the market segments for phone and for webcam, and those differences lead to some differences in KPI and how we measure things. So a lot of the same underlying approaches are used in both profiles, but some of the details you'll find are different. But within the VCX webcam specification, we have 24 KPIs. We have KPIs for visual noise, which is modernizing the way noise is measured compared to the legacy SNR method. We do have some challenges here that we're working on closing, and you'll probably see some changes in that minor revision spec. But overall, we think this is the right KPI. We have a KPI for contrast response. So notice there's a separation here between contrast response and dynamic range. This is one of those market force things. So in the past 3 to 5 years, ISPs across the industry have developed wide dynamic range enhancement algorithms. And in some cases, those algorithms work very well. And in some cases, they really work poorly. But that's different from the dynamic range of the sensor. What a WDR algorithm does is it really trades off highlights and details and noise. So we need to measure these things separately. So we have a KPI for contrast response, and we're closing a few gaps on that. And then we have a separate KPI for dynamic range, which specifically looks at the totality of that sensor range. We have KPIs for exposure accuracy and convergence, and Uwe showed off some of how that worked in his presentation with the video and the changing colors on the face. But basically, I wrote an algorithm that allows us to record a video of changing environments, changing the lux level, changing the color temperature, changing the background, and those changes happen in a known time segment. And based on that, we can measure the time it takes for the camera system to respond, the accuracy of response, did it respond to the right level, and also after it's converged, is that convergence stable over time, or is there oscillation? And so we have some innovative algorithms that do that. We have tests for resolution, texture loss, and sharpening. We use a different test chart, but overall we use a very similar method to what Uwe presented, and I'll have some pictures of the test chart here in a little bit. We have tests for color accuracy. This is one area we really didn't have to innovate. Certainly there's always improvements and state-of-the-art changes, but overall we found that what the ecosystem was already doing worked pretty good. So we're adopting a lot of the same methods that have been used traditionally over the last 10, 15 years. One thing we did add was a hue measurement. We have tests for white balance and convergence, which uses the same algorithms that we use for exposure with a few changes. We have tests for image uniformity, both in spatial and in color. And we have tests for frame rate, again, similar to what Uwe presented. So all of this is correlated to a user experience study, which I'll show a little bit later. All of the data is derived from captured video. This is one of the key differences between the VCX phone cam and VCX webcam profiles. The VCX phone cam profiles is more focused on that taking a picture and recording video, really using your phone as a as a photography device, which is what many of us do. The VCX webcam spec is really very focused on communication. Microsoft has shared in some of its NDA documentation, so I can't share the exact number, but well over 90% of camera use case on Windows is video using the front-facing camera. It's very clear that the primary use case or killer app, if you will, of the PC is video conferencing. It's how we connect. It's how we use it. We have a target for 8 hours data collection. We're not quite there, but we're most of the way there. For 3 resolutions, the whole thing is designed to be location agnostic, right? You should be able to set up a VCX webcam lab anywhere in the world with anyone, because we're a distributed ecosystem, right? We're not all in one place, and relying on a particular scene or a particular building or a particular person's set of eyes is not a scalable long-term solution. The test scenes are repeatable, they're programmable in a lot of cases, and they're really designed to limit the kind of, oh yeah, I have to go manually change something in the lab, procedures that often take a lot of time. And finally, the specification itself is publicly available at vcxforum.com. There are some pieces, job aids and other documents that are of course member only. But if you're not a member, you can download the spec, and most everything you need to know is there. So let's talk about some focus areas. We started, if you recall from the timeline, I had a remark there about pain points. The first thing I did is I reached out to OEMs and I said, hey, what don't you like about your cameras the most? What's the most annoying things about the cameras on your platforms today? And I got some good answers. And it was fascinating in that most of those were in line with the things that annoyed me the most. And then there were a few surprises. But we put that together into a list. And then from that list, we put together a list of focus areas. And these focus areas really drive the entire ethos, or the entire approach of how we develop the specification. First off, low light. And basically, these really define, what a camera should be and form a guiding philosophy. Webcams should behave in low light and in mixed and in changing light. They should be sharp, low noise, and color accurate, even down to 10 lux. Where do we get that 10 lux figure? An 11-inch PC screen at roughly 50 centimeters with a white document on it. We measure 10 lux at 50 centimeters. And so that's where we set our low light level. Certainly we could go lower than that. Phones definitely go lower than that, but we think that's probably a reasonable low light level, at least at this time. Changing CCTs and image brightness should not introduce color accuracy, shading issues, or inaccurate skin tones, right? The average user of a camera system, they don't think about, well, how bright is this or how dark is this? They just want their camera to work, and it should work regardless of what's going on in the scene. Face priority, and I'll talk more about this in the next slide, but face detection and any algorithms that rely on it should function reliably regardless of the size of the face, features of the face, or the skin tone of the face. Remember, we're using these cameras to communicate. Almost every time there's going to be a person, just like I am here in front of that computer. That person is the star of their show. It shouldn't matter what's happening in the background. The camera should take care of their face first. High dynamic range, video should be stable and prioritize the face, even in HDR scenes, such as in front of a window or some other bright background. This is one of the big pain points I got from all of the OEMs, is I said, hey, when there's a person in front of a window, their face gets totally washed out or totally black, and it's not usable. They need to be the star of their show, and the camera needs to know that. Challenging scenes. White balance should perform well, even with memory color scenes. So one of the things that we do in the lab environment is we have a television background, and we have monochromatic scenes. We also have memory color scenes, sky and trees and stones, some indoor scenes, and also some moving people, where people walk around in behind the scene. 3A convergence, I kind of talked about this already, but 3 algorithms. Misbehaving 3 is a major distraction, and it's a headache for every IQT. It often can be attributed to insufficient validation, and frankly, we've all been there, about to launch a product when someone finds just the right lighting condition that breaks everything. So the testing that we do specifically for 3A is designed to really challenge it and ensure that the kind of corner cases that we have experience with in the industry tripping us up are tested every time, not just when someone thinks about it. And lastly, we have a focus on motion. So this is not in the specification now, it's a future KPI that we're working on. But basically, the idea is that normal motion of a person within a static scene, right? It shouldn't cause oscillation, it shouldn't cause three-way reconvergence, it shouldn't result in ghosting or other motion artifacts. And this is important, as Uwe had pointed out about frame rate being important, but also today we have a lot of multi-frame algorithms. TNR and other denoise algorithms may use multiple frames. And if those aren't tuned correctly, then they can result in some very strange artifacts. So faces first. This is really what it comes down to. We're all the star of our own show. And one of the big pain points that I got from all of the OEMs was, hey, cameras don't handle people with different skin tones well. And they were absolutely right. I have some data to show you in a couple of slides. But what we found was, hey, a lot of cameras handle people that look like me really well. I think I've coined a term at Intel I use called accidental validation. When your tuning team sits in one geo, they're often all look the same. And quite by accident, then they're going to use their face for a lot of testing. And because of that, there's a lot of testing that doesn't happen with other faces. So based on our core philosophy of ensuring cameras work well for everybody, we've adopted these two mannequins as part of our test scene. So we worked with a Hollywood movie prop company to get these heads created. They're based on real people, molds and scans of real people. So we have a light skin tone mannequin and a dark skin tone mannequin. They're both, nearly every test is repeated with both of these mannequins, and they're equally weighted in the end result. And we see that in the test results. So cameras that do well with just one of these heads are, that's going to be reflected in the score, and cameras that do well with both of them is also going to be, positively reflected in the score. Because ultimately, reliable face detection and accurate skin tone reproduction is critical to a good end user experience. You can see on the right side of the slide here actually a picture of that memory color scene I was talking about, where we have the scene and then the background. And you can also see an apparatus we're using that actually, I guess I should talk about this in the KPI list, but one of the tests that we do includes rotation of the head, right? Because as you can see with me, I'm moving in the scene. My head is not always perfectly still and unmoving. And often we get distracted. It may be a small distraction. It could be a bird tapping on the window and you look away and come back quickly. In that case, you're still the star of your show. Nothing really changed. And so the camera should, handle that well. In other cases, maybe you get interrupted and you have a short conversation with somebody. Clearly, you're not paying attention to the camera anymore. In that case, if the camera changes, great. But when you come back, you're still the star of your show, and the camera should come back to where you left off. And so there's an apparatus, to move the head to be able to enable that test. Now, talking about the VCX score system, the overall approach is very similar to what you see in the VCX phone cam system. There are some differences. So you see a very similar tree. Our score works from 0 to 100 rather than 0 to 1. It's the same thing. Just when I wrote the tools, I used percentage based instead of decimal based. The overall approach is the same, but the weights and the KPIs and the scenes are different because the priorities for a webcam are going to be different than they are for phone cam. So the tree goes much deeper than this, but you can see what it looks like here. You can see that we have the score tree broken down into 3A. Well, really 2A because we don't have focus, but 3A, color, spatial frequency response, noise, contrast dynamic range, and timing. And then within those, we have them broken down into multiple smaller areas. And you'll see that most of them are broken down into no face present, which is kind of a control. And then the Richard, which is the dark skin tone, and Alexis, which is the light skin tone face. And you'll see the weighting there. So the no face is weighted much lower than the other ones. So individual image quality traits are measured via standard KPIs. Those KPIs are then transformed to compatible numeric metrics using lookup tables, which Uwe talked about earlier, so I won't get into that. But basically, each KPI has its own lookup table curve that's used to transform it into a percentage value. Those weights and transform curves were developed from real device data. We built a database of 12 devices that represented the range of performance in the PC ecosystem. And we looked at the data from all those devices. We identified trends that aligned with the user study that we performed, and that's how we built the system. So individual metrics are combined through a weighted sum, and then ultimately that weighted sum rolls up to the final score. So why does it matter? Because it's fully objective, it's reliable, and it gives you a score that's representative of subjective image quality without having to require on someone like me to look at the picture and tell you, is it a good picture or is it not a good picture? So a couple of spotlights I wanted to call out. We're almost done here. A couple of spotlights I wanted to call out from the data that we collected and we built the system on. First, the top chart on the left. You see results from our expert user study. On the left side, in the blue circles, are the results for the light skin tone, and the right side in the red circle, the results for the dark skin tone. And while I expected, because I have some experience, I expected a lot of devices to perform more poorly with dark skin tone. What I didn't expect is for every device to perform more poorly with dark skin tone. And this really reinforced our decision to approach it this way. The other thing that was interesting, chart on the bottom, this was the result of a small experiment. I think we need to do some more work with this. But what we found is the best performing devices in our expert user study, no surprise, had the least number of issues. That's the left side of the chart. But what we found was there was nearly a linear relationship between both the number of issues and the intensity of issues as devices went farther down in the end results. So again, this really reinforced that we're moving in the right direction and doing the right thing. So a quick look at this. I won't spend a lot of time on it, but this is the expert user study that we built the score system on. And so you can see the devices from top to bottom. At the top are the best performing devices, bottom is the worst performing, and then multiple lighting conditions that we tested in. So finally, that takes us to a couple examples, and I think most people can see the difference. So if we look at this first device, and we're short on time, so we won't go through all of these, but if you look at this first device, I think most people would agree that, yeah, this looks like a pretty good camera. You know, the face looks pretty natural. It's maybe a little flat, but it's not, you know, there's not a whole lot wrong with it. Color's pretty good. There's pretty good detail, pretty good sharpening. These artifacts are from PowerPoint. They don't actually exist. And then we look at this device here, which has a much lower score. And I think most people can recognize that, yeah, there's some problems here. There's a lot of noise in the background, and there's very low detail. Sharpening's pretty poor. The face is noisy, and features are not well reproduced. And so this really just demonstrates how the system works and how the score system works. A quick look at test lab configuration, what you need to build a test lab. I won't spend a lot of time on this because it's in the spec, but the message here is anyone can build a test lab. Certainly, if there's some costs associated with it, you'll need to go through a certification process. But there's really a handful of equipment and only 2 environments that we test in. One environment is what we call the webcam studio test chart, which is made up of the chart itself, the mannequins, the head turn rotation apparatus, a gray board, and the TV in the background, and then a uniform field device that allows us to illuminate both the flat field, which we use for shading tests, and the OECF, which we use for noise and contrast. Down here at the bottom, we show an LED panel we use for frame rate tests, and then here's a picture of the lighting system that we use to replicate all of the lights in the spec. Of course, the spec, you'll notice, doesn't call out a specific piece of equipment and say, well, you need that, but it does have pieces of equipment that have been qualified and working for the specification. So that's, I'm going to stop there, I think, because we're short on time. But thanks for listening to me, and certainly reach out. And if you have any questions, I'm always happy to help.
Well, first off, let me say thank you for inviting me today. I spent 27 hours coming here, and I appreciate you all being here. So I always love getting onto this side of the world. Today, we're going to be talking about how artificial intelligence can make images look better with less effort on the part of the user. And I'd like to also show you how this technology could be fine-tuned to the chips, the sensors, everything about your cameras to get a better experience. So one of the things that I've learned through the years is that hardware and software are intricately linked. And when you take advantage of this, you can get a lot done. So we're going to jump right in and talk about enhancing images with artificial intelligence. And I'm just going to start a timer so I have a background there. And we've left some time along the way for questions as well. And afterwards, during the lunch break, I'm happy to speak with any of you that we can. Let's jump right in. So a couple things here and jump right in. What we're going to look at is talking about a new imaging engine that is available to run on different types of hardware and devices. And I'm going to show you also that choices you make in camera have a tremendous impact. So one of the things that bluntly bugs me is some very common choices that are made for how cameras are pre-configured to capture images that really make it more difficult to get a good job. Things I almost have to always undo to get a good image off of my mobile phone or my web camera. And I'll talk a little bit about how AI will work with this, and I'll show you a little bit into the future, some things that are coming that will make things a lot easier for everyone. Now, this is not the type of AI photography we're talking about. So computational or generative AI, using AI to create content from prompts is not at all what I'm discussing. It's very much the rage, and it's a trend, and it's a fad. And I will tell you that my children will not look at this image someday and remember something fond that we did together. This brings back no family memories. This brings back nothing. Our photos are our most precious thing that we own. They are the pictures of our loved ones, the trips, our memories, our parents, our grandparents, our heritage. It's amazing to me how much these mean to us. And for so many of you, you are making the cameras that are capturing this. So we have an obligation to do a great job because what we do really matters. This doesn't matter. So we'll just get that out of the way. I have been a photographer for my entire life. I started by studying journalism, but what I can tell you about myself is that my mom was a school teacher as well as an English as a second language teacher for after the war. And my father was a NASA engineer who worked on things like Skylab. Somehow I ended up with the ability to speak to engineers, teach very complex subjects, and meet people in the middle. I've designed a lot of software for many years. I've worked with companies from Apple. My last project before I decided to go out on my own was working with Skylum, makers of Luminar and Aurora HDR. We received App of the Year from Apple for some of our technology. And along the way, I also have written about 40 books and 200 video courses all about video and imaging. And something I realized a few years back is that osmosis doesn't work. People buy books, they watch videos, they wish that they can learn these things, but they don't. And so instead of trying to teach people how to make better images, I decided to work with some friends to design AI that could do it and take the best practices of photographers and bring it to normal people so that they wouldn't have to make hard decisions. And we also pretty much threw out all the rules along the way of the things you must do when working with images. I have frequently through the years gone into different places to try to solve problems. So Apple, Adobe would send me into television stations, large organizations to try to streamline their workflows, to design new technology. I've worked with many television networks. I currently consult to Fujifilm cameras on some of their technologies. And pretty much, I've been putting video on the internet since 1995. So I've made a lot of mistakes when it comes to web video. But one of the companies I worked for was compressing video for Best Buy. And we were putting music and audio clips online in 1995, which means I'm old. But it was fun. We were covering bands. So that's who I am. In the back is also my partner, Florian. He's one of our co-founders of the company. And we're happy to let you walk away and play with our software. We can give you our desktop version. But what I'm going to show you today is the mobile technology we've been working on and that we're really excited about. So our company is called Radiant Imaging Labs. And it's a very simple concept. And that is that we wanted to really harness the power of light. Photography is about light. And so often this is forgotten. So we just started last year. Everyone who is an owner of the company has been a working photographer, has designed and made images for many years. And we were very proud that in our very first few months of existence, the Technical Lucy Awards nominated us for Best Product. We lost to Adobe. They have a much better marketing budget than we did, but it's okay. It was a good start to our first year. So we made this because we wanted to make sure that every image looked its best. And that's because images matter to people. Now, before I show you our technology, I want to talk about your technology for a moment and some of the choices that I repeatedly see made that I'd like to make you aware of, because there's a lot of things you could do just by changing what you already own and not spending any money, small changes to how you configure your cameras and sensors. First up, this is some of the most important stuff that's happening right now. And the more things you have on this list, the better off you are. So in-camera HDR and tone mapping is using what we can pull out of the sensor, using software to pre-process the image before the customer sees it. And many of you are already doing this and are aware that that helps. Long exposure, computational long exposure has been incredibly helpful. Low light mode, being able to stabilize a shot. I was amazed last night as we walked around the city and I shot on both a new iPhone and a newer Android device, how good it was that even though I hadn't really slept in 2 days and I'm 27 hours jet lagged, that I could capture great shots at low light photography at night and get pretty good looking images. If you are capturing RAW or a DNG, wonderful. For people who choose to buy a mobile phone, primarily because of the camera, which is a shockingly large audience, that is the #1 consideration is image quality or picture. Offering them RAW and DNG, one or the other, both, is pretty much a checkbox. If you don't have that, no one who considers this to be a primary reason to buy your device, they will write you off. Now, whether they use it or whether they even know if it's on or off doesn't really matter, because people just hear things on the internet and someone told them that RAW or DNG was important. Reality is it's tremendously important because we can have a 12 or a 14 or a 16-bit image. Now, most of you are probably far better at math than I am, but one of the things I like to get out of the way very early on is bit depth. So the HEIF and HEIC formats are a huge leap forward over JPEG. JPEG should have died 10 years ago. JPEG is crap. JPEG is nothing good. It just hasn't gone away. How much better image quality wise is an HEIC or an HEIF from a color point of view? Anyone want to guess? Just a simple number. It's actually, you can count it on one hand. Anyone? 4 times better. It's a 10-bit image by default. It can go higher, but most of them are 10-bit images. And you're thinking, well, 8-bit, 10-bit, what's the big deal? Well, this is 2 to the power of. So it's 2 times 2. It has 4 times more color information. This is huge. And this really makes a big difference when we go to post-process the image, because there's 4 times more information there. And as an added benefit, HEIF and HEIC takes up half the file size space of the JPEG. So you get twice the disk capacity with 4 times more color information. So if you're not taking advantage of this low-hanging fruit, innovate. It's pretty easy. And make sure you offer exposure compensation control. This is the ability for the user to underexpose a little bit because most cameras overexpose. Now, here's a couple things. I'm amazed at how all of the controls are constantly hidden. Oh, every single time I want to access them, I have to tap these 2 buttons. I have to swipe twice. I have to hit this button and forcibly add it. I understand. I design software, and I'm always amazed at how many times there could be 2 buttons and people will still click something random that isn't a button. Also, and this one is huge, stop overexposing. Someone decided that we needed to make images brighter because consumers are setting their screens to half brightness. Therefore, we have to overexpose the image so it looks better on the dimly screen. Don't do this. It's terrible. It is so hard to fix these images. I'm going to show you how we fix them, but it is basically throwing away most of the quality. It is so easy to take an underexposed image and brighten it than it is to make pixels out of nothing. Blown out pixels are gone forever. You can't recover them. And if you can, please work to get more color and preserve the highlights. Now, I'm going to move on to AI, and maybe everything I just said is what you're already doing. If it is, congratulations. I said earlier, I've been doing this for many years, and I'm old, therefore I'm opinionated, and I sound cranky occasionally. But I'm trying to be helpful, and I hope that these are easy things that you can implement. Are there any questions on any of those before we go into the AI part? So here's something I found interesting as I was just brushing up on current statistics. And this is in America, but the numbers don't vary that much as you move around the world. And basically, half of all people are using third-party camera editing or photo editing apps on their phone. Now, they tremendously jump around and they abandon one and they switch to another. But what does this tell you? It means that at least half of your folks are generally either yearning for something more than you're giving them or are dissatisfied with what you're giving them. So you have to embrace this and acknowledge the fact that you can do more. Now, here's the key takeaways before I even get into the presentation. First up, customers expect, and a few other folks said this today, that the built-in camera app and the camera is amazing. This is probably one of the most expensive devices they've bought. These are the same folks who used to spend less than $100 or $200 on a digital camera or a small, cheap film camera, and now they're spending way more than that. They expect this to be amazing. And if it's not, they're frustrated. And if they're frustrated, they speak badly. They also don't like switching apps. I tell you this as a person who makes apps. So really what I'm trying to encourage you is while we make an app and we let people install it themselves, we would so much rather that you just built what we did and put it inside of yours, because every time somebody has to switch from one app to another app, every single time they want to do something, they quit, they get fatigued. And so one of the great things about AI is that it can really make this easier for them. And so we would very much like you to consider adding AI technology to whatever you're doing, whether that be a web camera or a mobile phone or any type of device. All right, so what I'm going to show you now is what we do on a mobile device. We also work on desktop, but we've worked hard to make this work on mobile. And we have a very simple workflow. And what we've done is not unique. We just have spent 15 years building this technology. So, there's a lot of good pieces in here, and I'm just going to explain to you how it works. First up, you must analyze the scene. Every scene is different, and here's where it gets troublesome. What happens when you have a picture of a person at night holding food? Do you expose for the food? Do you expose for the person? Do you expose for the background? You don't know. And so AI has to make a decision of what's the subject matter. Or let's compromise here and aim for something that will do no harm. Then we have to apply responsive tools. Tools that will actually react to the pixels that you're applying them to. Not global tools that apply a global adjustment, but software or technology that can do masking under the hood or adjust up or down as needed for the pixels you give it. Because you can have dark areas of a photo and other areas of a photo that are perfect, and you don't want to affect areas that are already good. Stop adjusting things that don't need adjustment. Then one of the things we've learned is we apply recommended edits. And when I show you the next generation of our app that we're building, or starting to build now, the second gen, you will see that we're taking an approach where we've gotten even simpler with things, where we have suggested edits and the user can just swipe through and decide whether or not they want to adjust. And then highly automated portrait enhancements. Many of you have probably heard of Facetune. I have a very difficult time with this app. It creates a lot of mental health issues. It's used by plastic surgeons. It costs an amazing amount of money, and there's all sorts of folks, including my daughter's friends, who have body health image issues over the types of pressure apps like this put on people. Yet it points to something, which is really, no matter who you are, you're at least a little bit vain. Meaning, if you have dark circles under your eyes and you don't think you have dark circles under your eyes, you blame the camera. If you're running around or you've been out drinking and you're warm, you don't go, oh, my camera is sensitive to infrared light, and therefore it's not its fault. That's just how infrared light works. You go, no, my camera's not as good. Maybe I should buy that guy's camera, right? So we expect these things to work. Oh, I'm all sweaty, I'm oily. Oh, the light isn't flattering, right? We all have an image in our brain of what we look like. Most of you probably use a headshot that's 5 to 10 years older than you are now, or younger, I should say. It's who we see ourselves in our brain. And lastly, we need to start to do more with color. People have become aware of color, and you've heard the concept of memory color. Some of you might be familiar with Fujifilm. During the pandemic, they successfully rose to the #3 position and were one of the few actual camera companies that were doing traditional cameras to see growth during the pandemic where no one else did. And it was largely because they didn't focus on selling the sensors or the technology, but instead they focused on memory color and the aesthetics and the feeling that their cameras brought out when you made images with it. Okay, so here's what we do. And I'm going to give you a quick demonstration. But simplified, you detect the scene, you then apply a smart preset, which is a starting point. Then you offer AI enhancement tools. We then go in and analyze tone, color, and details. Now, here's a simple thing if you're doing this yourself. Always fix tone before you fix color. Because when you change tone, you adjust the white and black point, you generally are affecting color. Changing color doesn't affect tone. If you do this out of order, it causes huge problems. The foundation of our technology is a true white point and a black point from the printing industry. So when we achieve true white and true black, everything else falls into place, and it's very simple after that. Those are the two things that matter most, getting a good clean white point and a good clean black point. You heard about details. And some folks earlier were talking about sharpening. Almost everybody completely over sharpens. Sharpening is important, but it is about 20% of creating a sharp image. Contrast, structure, texture, edge enhancement, all of these things matter. And lastly, our portrait and color grading tools. So what we see here, and I'm showing you now pictures that I made last night or the night before. So I don't want to just show you canned demos. I'm going to show you pictures that we took in the city over the last 2 days. So I haven't had time to, make these perfect. Most of you were here yesterday. It was a really rainy day, and we went out and made pictures. It was actually beautiful pictures, perfect weather for pictures. Let me show you some things here and what this looks like. I'm going to start with an Android device, and we'll go from there. Okay, so I'm tethered to the computer, which is mirroring to a projector. So basically there's like 3 levels of delay. So when you see a little bit of delay, it's much smoother on the screen, but you'll get the general idea. First up, we have the ability to actually batch process. This is important because most people don't like editing photos. They like pictures to look good. You say that's crazy. People love moving sliders and they buy these editing apps. No, they want results. They don't want to move sliders. I've been making photo software for years. And when I finally decided to make photo software easier, we start winning awards. Our desktop app has a 98% rate, a 2% return rate. 2% of the customers who buy it with a 30-day money-back guarantee and a 14-day trial, only 2% of the people who buy it return it. Why? Because we made it easy, and that's what they want. They say they don't want easy. They say they want control. They don't. People want results. So we added the ability to batch. And so I just have a bunch of images here that were captured around the city last night. These are actually all from last night. And I'm just going to hit next. Okay. One of the things here that's important is recognizing the scene. So here, it treated it as people at night. You might be saying, well, why not just night mode? Well, people need to be exposed differently than general landscapes because we as humans know exactly what skin tones look like. And when those skin tones become overprocessed, we become very bothered by what they look like. Now, I want to point out, here, this is mostly not people, so it went to landscape at night. But as cameras tend to overexpose, see, we're bringing back quite a bit of data, but if this just didn't start so overexposed, it wouldn't have that problem. Stop cranking up the exposure and let software afterwards recover the underexposed areas, because otherwise you have blown out areas like that that just scream, oh, this is not a great picture. Okay? It just can't handle it. Now here, I went into the camera and I talked about those manual controls. I set it to 2/3 of a stop underexposed. By the way, that's pretty much the magic number for every cell phone camera I've ever photographed with. If you would all just lower it 2/3 of an f-stop, the world would be a better place, because look at this little area here. Look at these signs, right? Here's what the camera did, and here's what software can do to bring it back. As we go down here into these shadows near the bottom, you see all those areas there, you can see it's coming back. And this was just the default. We have responsive technology. So besides the automatic method, we basically start with a tiered system. Strength is all the tonality adjustments with one single slider. Color is everything to do with color adjustments. This is for people who basically want control, but don't want to be switching buttons and bouncing around. Makes it very easy. And look at how much information that was lost comes back, right? Look at the sharpness as it comes back. That's important. But if the user wants to keep going, then we get into traditional photography techniques. The best one here that I'm most proud of is light diffusion. So light diffusion is a softening of the light. I'll take it all the way up. This is a standard photography technique to diffuse light so that it reduces the harshness or the fall off. And so what you'll see is that it fills in things without being so over the top. Okay, now let me just go back out here. Actually, we'll go right in here. Swipe, swipe, swipe. Now, food. People love taking pictures of food. Not everyone, but you all see the folks. They take out 2 cell phones, or they have a small light in their purse and they're trying to avoid the shadow. But when it comes to food, we want to see details. We want people to feel like they were there. Contrast, detection. Every sensor softens. So sharpening is important, but edge structure and color contrast is more important. Color contrast is adding blacks into the color areas, not overall contrast, but taking colors that lack black and injecting it. Why black? It's tied to the printing industry. A nice contrasting image for print. It actually does translate to the screen as well, and adding richness into the color areas brings out the feeling of contrast. Now, portraits are always challenging. So here, this was shot on the phone from Samsung. And this is a few years older as a phone. I always like to use not the latest phone, not because I don't appreciate the latest phone, but I feel like I'm cheating. If my answer is, oh, our software works great if you always buy this year's model, I don't feel that we're challenging ourselves to work with what most of the market has. With people, we have to do a little bit more because we know what a skin tone looks like. Now, photos with masks have gotten really challenging, but as you see here, there's a lot we can do to lift folks out of the shadows. What gets more challenging is scenes like this. This has pretty much every problem in the world in one photo. Okay? It's pretty much a nightmare photographically of trying to, from a technology point of view. Handheld, late at night, high reflection, metal surfaces, movement, people walking all directions. Okay. So the cameras these days do okay with a longer exposure, hold it together, but look at what we can do. And I want you to pay attention in the downward area here. Look at what happens in the street here. When we achieve a true white point and a true black point, look at how things look sharper. And so you can see that in the crosswalk and in the street. So it becomes important to pay attention to those areas. Now, in our case, auto radiant is the AI equivalent of going cat dog. I don't know, I give up, okay? AI often fails. So if you're using AI, you have to have a fallback position. So when the computer vision is unable to say, I don't know what this really is. I see plants, I see something human shaped, but it doesn't look like a human. The skin tones are off. There's these large bright areas. Okay, I give up. Let me just do a general enhancement and try to even out the exposure and fill things in without overdoing it. That's important because AI will always fail about 10% of the time. 9 out of 10 times, computer vision can correctly identify a scene. The other 10%, it's going to fail. If you don't have a fallback, you don't have a good app. Now, one of the things I want to point out here is having a smarter traditional adjustment. You all know what an exposure adjustment is and a contrast adjustment is. Most of the time, when you adjust exposure, everything gets brighter. When you add contrast, everything gets more contrasty. This never works. This is why people use tools like Photoshop and Lightroom and make selections and masks and paintbrushes, or back in the day, we dodged and burned. But AI can also recognize edges and masks and do things under the hood. So when we raise our exposure here, notice how the light is changing in the background, but the lights hanging in the foreground did not completely blow out because the AI is able to say, those are already as bright as they need to be, so leave them alone. By identifying something that's already correct, you can turn your attention to the parts of the photo that aren't correct. And this allows you to make the picture better. But users don't want to paint with their finger to mask things out. And yes, you can long press on things to erase them or loosely draw around them on Android and have it try to find the edges. That's way too much work, right? A user expects, oh, add more light. Cool. And then, oh, add more contrast. Okay. And I pretty much pushed that to max and it held it. Oh, soften the light. There's different levels of AI. And what I mean by that is ultimately we want to just get it right. So let me go here purely automatic. It's food and drink. The user loves the fact, again, handheld at night, just a night market, right? Look at the edges, look at how it comes together. I want to point out that we are not doing practically any sharpening. This is what it looks like when you over sharpen. Okay, see that? That is awful. All those extra black and white lines. This prints terribly, it looks terrible. The key is not sharpening. Sharpening serves a single purpose, which is to overcome the fact that what the sensor saw had to be compressed when it was written to a file. And so this is compensating for digital compression artifacts. It doesn't compensate for anything else. And if you over rely on it, it produces problems. Instead, you want to deal with intelligent tone. So here we are restoring proper black and white point. And push that even further, and you have what you want there. So I'd like you to learn to pay more attention to the blacks in a photo and the white point. But the number one problem is that if you look on a histogram, you will see that there are gaps, large areas where the black and whites are missing, and it's very difficult to get the right contrast because you just do a push and pull. So by letting the computer mask things, we don't lose the tablecloth. In fact, we bring back missing detail. Okay, so let me explain what's happening under the hood there a little bit. First up, you have to have scene detection, and scene detection is amazing. Scene detection can do so much, right? And I want to point out that it doesn't have to be heavy, right? So here is, I'm using Mylio Photos. I have some friends that work on this, and I've consulted on this as well. And every one of these pictures that I captured yesterday on my phone is going to have information about it, right? it's going to know details about what was there. Oh, there's a building, a place, a vehicle, water, right? It's starting to recognize the content. These are all unedited. Oh, okay, eyes are open. There's a person in this one, right? Oh, there's a lot of color and yellow, right? It's able to start to find things because as a user, I expect that, I could just say, oh, I was looking for my friend and we went out the other night, show me pictures of, beer glasses, right? Let me find glasses or let me find other things. And so all of this stuff that you're seeing here, all of this computer vision is running offline. Nothing is sent up to the cloud. Nothing is invading people's privacy. It all just runs on device and it can run on mobile. So AI computer vision models like Onyx can be highly optimized for mobile. So a user could just say, oh, show me all my photos of beer glasses, right? I want a picture of when I was out with my friends. And this is a library of 500,000 images. Now, I'm on the internet, but it's not using the internet here. Everything's running local. And so I just put that out there that you might consider that between computer vision to help identify how to edit a photo, computer vision can also identify what's in a photo. And when you combine that with GPS tags and face tags, then you can find things. Because the other thing that gets really old is watching people do this all day. People want to shoot and edit and view and do everything within your camera app. So make it better. The AI has to be customizable. One of the things we've learned is that every device is different. So it's no good for us to make AI that only works one way. So you can go in and fine tune it. And you want to have portrait tools and a focus on color and exposure. Now, what we've done is, and some of you may have heard of these folks, we licensed an engine called Perfectly Clear. And it's been around for a long time. I actually worked on it for the last 6 years, and I've designed about 50% of the features that are in it. But what I decided to do was, rather than start all over, is I just licensed it and said, I'm going to build on top of this, but use what I like from it. And 140 million images a day go through this engine. It's basically what every print lab and every store that's doing printing or kiosk printing is using, and a lot of the photo labs look. And here's the thing, when I talk to most people these days, everyone wants to tell me how dead printing is, that nobody is printing. They are printing all the time. And knowing about print is important. So what do? Smart presets, these look at the image and get you to the right point. So we say, are there people or not people? Is it underwater, black and white? We break it down. And then we're able to make a recommendation. So we can analyze it and then come back and say, this is what we think it should be doing. We do this because it will let the person jumpstart. And with no interaction, they get better, more accurate color, more detail. We want this just to work. Then we take those AI enhancement tools in. Now, one of the things we've worked really hard on is to make this work with video in real time. We don't have all of the things working with video, but we have the tonality working with video. And so I want to show you what that looks like. These are all real time, but I'm going to show you the live device now so that we can judge it from actually seeing what's there. So let me switch to the iPhone for a second. And I'm just going to go to my overall library here, and I'll select some video shots. Okay, I'll do all, in fact, because we can batch process video too. Now, if the video is not on the local device, which is pretty common, you have to fetch it. And this is where people get really bored. But notice here how we can go in and take what is not great, pretty good, and really bring back the color and the detail. Incredibly high contrast scene. This is all playing in real time on the device. Works with web cameras as well. This is about as high contrast as you can push something. Tons of light and shadow. Harsh outdoor lighting, right? So we're pushing this so that we can get a little further. And the true test is always nighttime video. What happens when you have high contrast areas? Look at the skin tones coming back, right? We need to be able to handle things and be able to get in there, right? Concert photos. true blues and greens, skies, right? This again is a nightmare concert photography. There's the enhanced image, okay? So it becomes important that people can get, look at the clouds, blown out, brought back. So it's not that hard. And one of the ones I love is this one. Again, this is a really tough test scene. Pay attention to her jacket. So you're going to see the highlights coming out, right? No enhancement. She disappears, bringing it back. But making sure that we don't kill skin tones, because as soon as the skin tones go away, the person instantly discounts the image. So what we have learned in and out is that skin tones matter. And if you don't preserve them, then people are going to be unhappy with you, is the nicest way to put it. Okay, so let me wrap some stuff up here, and I'll just tell you that what we wanted to do is really tackle the corrections. So we decided to focus on rich color, but no tint, so that as you boost color, things that are supposed to be white are actually white, clouds. That we have great highlight recovery, good edges, blue skies. So here is a simple automatic adjustment. What I shot on my phone 2 nights ago, automatic exposure recovery, okay? And it brings out the feelness of sharpening. Backlit scenes. This is 100% automatic, no masking. That's what the camera got. That's what we bring out. When you underexpose, you'll be amazed what can be rescued with software. When you overexpose, you can't. So by exposing for the sky and the sun, we could still rescue her. And then we talked about color restoration. That's putting the blacks back into colors so they're rich. Not increasing saturation. Recovering highlights. Notice the sky and the dress. Trying to look at white and find texture within it goes a long way. And then, of course, sharpening does work, just don't overdo it. And here's something I'm very proud of that we're working really hard on right now, and that is skin tone detection. So everyone has something in common, which is the blood in our veins. If you've ever worked with a colorist in the world of video, or you've looked at a video scope, a vector scope, there's a line referred to as the flesh tone line. It's the color of blood. It's about right there on a circle. And it doesn't matter what your skin tone is. It's what we have in common. And we can isolate that and properly adjust. But most cameras are fine-tuned for people that are my color skin or the lighter skin tones of most of you. And half the world is ignored. So we have worked with some very famous photographers who are well known for photographing people with darker skin to properly handle it so that as we brighten the skin, we don't change the underlying value of the skin. And so we've built a 10-point detection. And lastly, have fun. People want things to play with. So that's where our color grading tools come in. So this allows you to add mood by making the colors engaging, by giving it a visual style. And here's what's amazing about this. So earlier, I mentioned a true white point and a true black point, and you heard lookup tables earlier, LUTs. LUTs are incredibly creative. They are film stock recipes. So Fujifilm, when I mentioned how they have all of these digital film stocks and they're well known, all of those are lookup tables. Most people can't use a lookup table correctly because it doesn't capture the feeling right. But when you have an accurate white point and an accurate black point, lookup tables are amazing, and they can instantly create all of these traditional film stocks that we've seen for years. And so they become incredibly easy for us to use. So we've built these in, and a user can very quickly audition different styles of film and many more. And all of these are evocative and are fun. And we're about to add 2 more controls that we have in our desktop product. I just bring that out because this is where people do want to play. They want their images to be automatically fixed, and then they want them to look better than everyone else. The other thing I mentioned was the need for portraits. And so let me just finish that, and then we'll wrap up. So let me share my screen. I don't like to make anyone feel uncomfortable, so I am going to work with an ugly model myself. Therefore, the only person I'm judging is me, okay? So we'll keep that simple. So let me go in and just grab some standard people type pictures. By the way, one of those nice advantages of underexposing is you can get amazing color like this, right? Handheld shot, just shot underexposed, let it come live. But let's do your typical person problem. So when we take pictures of people, this is what we get, right? It's going to be high contrast. And we fix things here, but this is 12 hours into my 27-hour flight. Okay. People are like, you're not smiling, you should smile more. I'm like, I just sat in coach for 12 hours and I got another 15. No, I'm not smiling. But here, I don't believe in adding fake smiles or fake teeth, but let me show you some of the things we can do instantly. So first up, this is that idea of a tiered interface, right? Let the user just choose simple presets that give them different results. For example, rugged skin or middle age, right? Middle age is basically a preset designed for people like me. I'd like to think I'm young, but I'm not. And as I go in here, I can do things like, oh, and let's take a look at those eyes. Enhance the eyes, sharpen them. And let's go ahead and just take all those dark circles out from underneath, right? So dark circles, before, after. We didn't clone, we just pulled out the color of excess blood that is unflattering. And, oh, on the face, let's go ahead and with our skin here actually, let's remove the shine, the excess shine on the skin, get rid of the hot spots, right? So it becomes easy to fix things. It becomes easy to deal with different types of lighting conditions and fill in things even in tough situations. Okay, it's my daughter with me. And you have to recognize these and keep it simple. So people want this to not be hard. And I would advocate that we shouldn't overdo it. People just want things filled in a little bit and to not be so shadowy. First up, as we said, we'd love to let you all go home and play with it. So at the end here, feel free to see Florian. And he's got a copy of our desktop software like this, so you can all play with it. We'd be happy to let you do that. What we're doing next is completely changing the user interface of a camera. So we decided that people want the camera to do everything, but they don't want to change settings. So we've made a very simple approach. You point the picture at what you want to take a picture of, and scene detection immediately kicks in and recognizes the subject matter and provides a live preview adjustment that makes it look better. Then, when you're done, it will suggest edits based on your subject matter. Oh, this is a teenager. We did age estimation. Here's a collection of 6 simple presets that work great for teens. Swipe through until you find one you like. If you're still not happy, then tap the edit button, and we're only going to show you what matters. So take a picture, auto enhance, provide suggested edits that are categorized by the subject matter, and then allow simplified controls. Stop giving all these overwhelming stacks of sliders. Only show them the tools that are needed for the scene. And we can make that decision and be right 95% of the time. So that came from years of studying people and watching them edit. I'm sharing my idea with you in advance. You can steal it. We're a company of 4 people. We have no intellectual property department. But what I will tell you is that we would much rather work with you to make things look better. And I hope today I gave you some ideas on how to take your existing tech and make it better, how to lean into object recognition, which will both help people find their photos and can do semantic segmentation to help create better adjustments to start, as well as better masks automatically. And then by applying smarter tools, tools that work with single sliders but do what other tools take 10 sliders for, customers are happy. And what we've discovered is that people go through basically 4 stages. First up, they just want to work. They just want to capture the photo. They're so nervous about missing the picture. Then they realize it could look a little bit better. And if it's automatic, they're completely happy. Then they realize that, oh, it could be a little better, and they start to play. And then they achieve that last stage, which is, I just want it to be better and look better, and they start to get creative. But you all have the home field advantage. You make the devices. Your job is to put the best software with the best hardware and to make sure that people never leave your app. And right now, half of them are desperately looking for other apps, churning, trying to find a better camera, and you can fix that. So thank you for inviting me to the other side of the world, and I'm keeping you away from lunch. We can open up to any questions, or we can talk during lunch. Okay, thank you so much for having me.